if you talk about, as I said in my last session, that in OT, the prime responsibility is you have like zero downtime. There is no like 0.5 margin, 1% margin of a downtime. In OT, mostly in manufacturing concerns, power sector, energy sector, water sector, increasing a certain threshold can have such damage or catastrophe that can cost human lives. Similarly, uh, you take like energy sector. If certain sensors or connectors are not working properly, or the right values are not getting passed to the sensors or the detectors, there can be huge explosions. Take your houses. If your house receives like normal is a 220 volt, but due to some cyber attack, if all the entire grid is receiving like 440 volts, the entire equipment of your house will burn out, and there will be definitely some casualties as well. So the entire world is not ignoring this part of a security. Before we started this session, I was talking with Shahzad Bhai that yeah, the most of the test bed is not available in the market for all the people, so they can practice and they can learn about SOT security. So to block attacks and to stop people learning from the platforms helps us to reduce the cyber attacks as well, which is called as security through obscurity. So by building this security through obscurity helps us to not transfer the knowledge to the bad guys so they can prepare things and they can attack the networks. However, these test beds or these things are usually available. If you go to a lot of OT environment security certification, they also provide certain kits. So these kits.
Welcome to Global Information Security Society for Professionals of Pakistan.
Assalamu alaikum and hi to everyone. I hope I am clearly audible. My name is Amir Siddiqui, as Shahzad Bhai has introduced me. I am working here in Muscat as a cybersecurity consultant. Before that, I have nearly 20 years of experience, mostly working in the banking sector of Pakistan. And I have also worked in Saudi Arabia for a retail firm. Mostly, definitely, my consultancy assignment here in Muscat is at Oman airports. And Oman airports, if we say, so there's a lot of OT utilization on all modern airports. And my one of my biggest challenges to assume this role was to understand OT setup and OT environment. So as I'm learning also, I got this platform to share my knowledge with my all peers in the entire world, and inshallah we will be exploring more with the future sessions as well. Yeah. So my target audience, as I said before in the last session, mostly the guys who are working with ICS and OT security. Lastly, we have seen a lot of OT-related regulations coming up in the GCC region. Saudi Arabia most prominently is working in like entire OT environments and automation areas. Qatar has released a lot of control frameworks on OT security, and similarly, region that I'm working in, Oman, has also released a lot of OT security guidelines, which is also enforced by, since I'm working in aviation industry, so the ICAO, the international regulator for aviation industry, they have also released a lot of OT security guidelines just to make sure that passengers and airlines security is intact. with all the modern day attack. If you talk about, as I said in my last session, that in OT, the prime responsibility is you have like zero downtime. There is no like 0.5 margin, 1% margin of a downtime. In OT, mostly in manufacturing concerns, power sector, energy sector, water sector, increasing a certain threshold can have such damage or catastrophe that can cost human lives. Similarly, uh, you take like energy sector. If certain sensors or connectors are not working properly, or the right values are not getting passed to the sensors or the detectors, there can be huge explosions. Take your houses. If your house receives like normal is a 220 volt, but due to some cyber attack, if all the entire grid is receiving like 440 volts, the entire equipment of your house will burn out, and there will be definitely some casualties as well. So the entire world is not ignoring this part of a security. Before we started this session, I was talking with Shahzad Bhai that yeah, the most of the test bed is not available in the market for all the people, so they can practice and they can learn about SOT security. So to block attacks and to stop people learning from the platforms helps us to reduce the cyber attacks as well, which is called as security through obscurity. So by building this security through obscurity helps us to not transfer the knowledge to the bad guys so they can prepare things and they can attack the networks. However, these test beds or these things are usually available. If you go to a lot of OT environment security certification, they also provide certain kits. So these kits help you to simulate the OT environment where you can test and you can do the labs to get the OT level certifications. And the last part of my presentation, I will make sure to complete it within time, is about those certifications as well, that what you can learn if you have to be qualified as an OT security specialist. So we will quickly go through our last session. In our last session, we have explored a lot of terms related to ICS architecture, what industrial control systems architecture is. I don't know from where this red line came. I think I have been compromised as well. Okay. I have not put these red lines. I don't know. So starting few terms from our last sessions, we have gone through the business, the main building block of automation process. The automation process is this is like a data flow diagram, sort of a data flow diagram to understand a typical automated process. Here we are seeing a lot of terms called as dynamic variable, process variable, set point, transmitter, controller, interface, manipulated variable, and agitator. So all these components that you see, they made up and they end as key component for any automation process. So remembering what these points are, within the block that is labeled as process, we control a lot of variables like temperature, pressure, flow rate, any rotational speed of certain motors. That has certain values and certain thresholds. So they should not bypass those thresholds, or they should not get down on those thresholds. So any parameter, it can change spontaneously from like external influence or from a dynamic variables. So the process variable is the point where it is all accepting the external variables, and it can be controlled by this controller block that we have seen. So we set certain points whatever the values are coming from the behind, they are like kind of a dynamic variable. So this set point is a place where you fix those values, and you don't want those values to be crossed. Okay, there is a certain pressure of water that is coming from a separate system inside another automated system. Now you need to control that pressure. So the level of water, or the pressure of the water that enter into certain system, for instance, it's a boiler. So if you have to enter water pressure with a certain pressure inside that automated process, so you need this set point to set a value. So whatever the process variable is sending that value, it can be controlled over here. Similarly, PV is a dynamic variable because it has a lot of external influences in controlling the flow of water, like river stream. You cannot control a river stream if there is a dam, and there is a lot of water coming from behind. So that is an external value. You cannot control that natural stream. A lot of rain is happening, and you have to make sure that you disperse all water from your dams to control the backflow. So there will be like certain sensors that will be working on the backflow, and they will be giving certain values to the dam main control system, so that they can open the gates and they can release the water before the dam crosses certain threshold, and water spills into like human population. So this is called as a dynamic variable, or we call it as a PV. So moving on, similarly, we will be getting through this image a lot as we have done it before. So there are certain OT environment important terms that we have discussed in last presentation. I'm starting it from I'm giving this reference from the last one because we might be a lot of people coming in and they don't have any idea about it. So we don't want them to be noise in it. So closed loop systems, like closed loop systems or closed loop control systems, are systems that don't have any external connectivity. They're working alone. Industrial process controllers and their key requirements is the availability, timeliness, industrial interfacing, and physical hardening. So what usually we mean by these availability, timeliness, industrial interfacing, and physical hardening. So usually when any industrial process controllers work, the controller that you have seen in the previous file, uh, these controllers have certain thing to perform. The heart of any process control system is the controller. So now the controller is responsible for taking the input information, comparing that information to certain conditions, making decisions about it, and finally sending whatever corrective action was required to ensure that process is running smoothly. So to ensure that industrial process controllers they are made of like microprocessor based computing devices. They are designed by the IT industry peoples who process them, embed like softwares into them, and they become like independent operators until some human intervention is required. So the important factors that are required for any industrial process to work is the availability, timeliness, industrial interfacing, and physical hardening. Like, okay, there is a microcontroller that needs a lot of information from other processes to decide something. A lot of sensors will be sending that information as an input, and that microcontroller, or microprocessor will be working and converting that entire decisioning that what needs to be done out of those values to the output. Like I said, a lot of water stream is coming from behind due to certain heavy rains. So now the controller will know which gate to open on certain threshold or certain value. So he will be opening the gate to a certain level so dam can hold the required water and can release the level of water that is not required. So a lot of things are linked with this industrial process controllers to make sure that process is running. Similarly, if you go like on the electrical grid level, there is a certain thing that grid need to transmit certain electricity to certain household. If you are using more electricity, more will be transferred to you. But if you are not using more electricity, it will not be transferred to you. So this is how the industrial process controller works. They send the required thing to required area depending upon what are the requirement, what is the availability. So the field devices that are usually part of any OT environment are the PLCs, programmable logic controllers. We know them very well. They are from old ages. We have seen a lot of big boards inside companies or electric companies have a lot of lights running down, a lot of meters showing certain values. So all these things have now been converted into softwares. So the entire old PLC boards that you have seen in certain images have now converted onto LCDs. So and those same meters, lights are now on LCD into a software panel where you can see those values, and you can, if human interface is required, you can take over certain process and do handle it any emergency situation. The RTU, remote telemetry units that we discuss that are famously used in smart metering systems. So you have like smart meters spread it inside your home networks, and from there they are sending that data to certain RTUs. Those RTUs are sending that data to the centralized, distributed control systems that are that are collecting the readings of meters, and if any thing bad happens to those meters, they can attend it then and there. Like mostly in advanced countries, we have I said before in the last session as well, we have like prepaid meters. So yeah, as soon as you prepay the electricity, you install a certain number in it, the electricity is the electricity comes into the house, and as soon as that units are expired, you have to renew them. So the entire environment is connected through these RTUs. The smart meter or the prepaid meter is basically an RTU. It's just sending certain information to the its distributed control system, which is saying, okay, now yeah, I know that this guy has paid this amount. Kindly release the electricity. So electricity will come to his house. Intelligent electronic devices. Mostly the RTUs have now, they connect with these intelligent electronic devices, which are IDs. These IDs, what they do is they collect this information from all of the environment, so they can prepare better results from whatever data RTUs are collecting. So primary purpose of RTUs is to make sure that the data has been sent and data has been received. But before, RTUs were not there. So they were like normal PLCs and there was no automation. So the entire automation is being received by the invention of these RTUs. They are very small intelligent control units that you can deploy on several locations. You can set certain processes inside them. They have like memories as well, so they can store certain information as well. And the good thing about them is their output is usually digital. PLCs are normally analog devices, but the RTUs have a digital output. They can take analog as an input, but the output is digital. So that way they can connect with the intelligent electronic devices, IDs, that I said, through certain communication port. So IDs are basically an RTUs as well, but they have like more enhanced intelligence of performing things then and there. Like I told about prepaid meters. So you enter the number and you save it, electricity comes to your house. So there is the IED. It has an intelligence, it's an RTU that can decide what to do based on communication with certain external system. So going on further, these like RS-232, RS-485 Modbus, they are like industrial communications, protocols. They are being used to all these component RTUs, IDs. They interact with each other. So they use these protocols to exchange the information, which we will explore in our further slides. Distributed control system, when process becomes too complex for a single controller to handle, be it they are geographically segregated. One control system is working in one country, one is working in another country. So you have a large network to manage. So you use these distributed control systems, which is like distributed OTs sending data to IT environment, and that IT environment sending that data to the IT environment, and then those local IT environment are sending to their connected OT environment. So this is how the distributed control system work. The word supervisory control, we have discussed it a lot. Supervisory control is basically a server inside a typical OT environment, which has a capability to take charge when anything happen in an emergency condition. Field buses, we have explored. These are the network pipes that connect all the OT devices, whatever means of media they use or whatever protocol they talk about. Their field buses are used to be called to the cables, or whatever means of communication is there, that make sure that all OT components they are connected to each other, which they are called as OT. So supervisory control, like I said, is basically it's a server like here, which can take which is connected to the entire different sub processes. These are like automated processes working in sequence. They have their respective controllers. Like I said, this is like field bus, which is providing like PVs, right? The PV, the point where who is sending like dynamic values to it. They are sending this data to each other. Okay, I have done this, now proceed to this. So he will say, okay, I will take process from here and I will complete this. So as soon as he completes something, he will come here and he will say, okay, start something from here. So he will take control and he will complete the process. So these entire processes, they talk to each other via this field bus, and this field bus has this supervisory control to take any if there's an emergency condition, and these are not working as per their logic. So you have to take the master control and you have to override the process manually. So these are like fancy displays that we see in all the OT environment deployments. This is like a data historian. A data historian used to store all the logs, because these devices don't have any memory. Their main purpose is to ensure the availability. So the data historian is basically keeping all the logs from these controllers. Then we have these engineering workstation. If certain component inside any process needs to be reprogrammed, or you need to troubleshoot anything like updating a firmware or something else, you can use these engineering workstations to connect to them and you can override this. On top of that, we used to connect with this router or firewall. We can take it and we can connect it with the enterprise network servers, which can have like normal enterprise IT environment. This is the point where IT OT interaction happens. So these are the words. Now talking about SCADA system, SCADA is supervisory control. This is one word, and data acquisition system. Now, if you go in that picture, if you see, there is like supervisory and this data acquisition. So the entire manual things that used to happen in the PLC environment, with the advent of RTUs, now normal PLC can only connect to this environment if they have like smart converters. So the RTUs, they act as a smart converters, and now that enterprise network can be connected to these RTUs and via this engineering workstation, and you can write any program that you want to. So these SCADA systems are composed of two elements called a supervisory control and data acquisition system, which is called as SCADA. Usually it was thought before that SCADA is mostly restricted to electric systems, but not. SCADA is not limited to electric systems. It is you take any operational environment where automation is there. Like I used to work at airports, so normally at airports there are a lot of machines that are working in sync. Flights are coming, they're taking out the baggage is going to the respective belt. So all the baggage they are putting it on the main belt. That main belt is taking to the subject respective belt where certain flight people have been informed. The display is saying that okay, your flight baggage will come here, so you stand there. So all these things are part of SCADA system. So they control it through the SCADA system. If you're standing on a certain belt and your luggage is coming on another belt, so that's a kind of embarrassment for any airport. But unfortunately, it usually happens in our country, so we are used to it. But in modern country, this is a very bad reputational issues. So if you have issues with your SCADA system, this will often happen. So SCADA servers, they are called as SCADA servers or SCADA masters. Like here, you can see a typical deployment of an IT environment and OT environment. So here, you can see that in your previous image, the entire bus is here. PLC's environment are here. And you have all your fancy devices like RTUs, motor, and all these things connected here. These are like RTUs here, which you can see. The RTUs are connected with the PLC, which is performing the main automation. You have human interface machines as well. So if anything needs to be bypassed on this PLC, HMIs are here. And these are like SCADA servers. Instead of data historian that we have seen in last image here, we have now brought a SQL database server. It is now the logs that are getting into data historian server are now getting into this SQL server. We have like engineering workstations as well, which can connect to the OT environment. We have like clients here as well, who you can call as are the monitoring view. You can print certain data if you want to. You're monitoring certain belts or certain supply chain, so you can see it here as well. So how they talk to each other? They talk to each other by system telemetry, which is called as system telemetry, is the language that all these OT environment used to interact with each other. So IT/OT integration, once again, a very important area. There's an association which is called as Industrial Association of Automation, ISA. They have prepared a standard which is called as ISA 95, oftenly known as Perdue Enterprise Reference Architecture for ICS Cybersecurity. It is same like in OSI. In OSI, we used to discuss the journey of a packet as it comes to certain environment and as it leaves in certain environment. So, but here we are discussing the flow, the level, like level 0, we discuss about physical protection of OT environment. In level 1, we discuss about production process sensing and manipulation. This is the place where you have like mostly OT devices talking to each other and performing certain flow. MOM is manufacturing operations management, which means that this is the place where all operations are running. This is the enterprise network level. This is like SCADA is here, and this is like where your entire OT devices are. So we are not discussing level 0 here in this picture, but level 0 is also here where we used to talk about all the physical protection of these devices. Level 1, level 2, level 3, and level 4. Level 4 is the place where IT is. Level 3 is the place where IT, OT are talking to each other. Level 2 is like entire OT, and level 1 are like PLC area where normal PLCs and all these things are working. You see these words Ether, CAT, and ProfitNet. and Modbus, Profibus. So we'll talk about these words. These are like network communication protocols of